Hi, so for this problem we're going to solve the derivative of inverse cotangent of x. Let's start by writing y is equal to inverse cotangent of x. Let's apply the cotangent function to both sides of this equation. Notice these two here cancel, so we're just left with cotangent of y equals x. Now, at this point we're going to want to differentiate both sides of this equation with respect to x. Let's just go ahead and do that up here. So notice here we have a function in terms of y and we're differentiating with respect to x. So we're going to have to differentiate cotangent of y implicitly. So we're going to have minus cosecant squared of y multiplied by dy over dx. This is going to be equal to the derivative of x with respect to x, which is just 1. Now, let's go ahead and divide both sides of this equation by minus cosecant squared of y. So we're left with dy over dx equals minus 1 over cosecant squared of y. We've just moved the negative sign up top here. Now we're going to have to make use of the following trigonometric identity. Cosine squared of y plus sine squared of y equals 1. Now let's go ahead and divide everything by sine squared of y. So we have cosine squared of y over sine squared of y, that's just cotangent squared of y, plus sine squared of y over sine squared of y, which is just 1, equals 1 over sine squared of y, which is just cosecant squared of y. Let's substitute this into this equation here for cosecant squared of y. So we're going to have dy over dx equals minus 1 over cotangent squared of y plus 1. Now remember, right here we wrote cotangent of y is equal to x. So if we were to square this, we would be able to substitute x squared into this equation here for cotangent squared of y. So let's go ahead and do that. So we have minus 1 over 1 plus x squared. And that's the answer to this problem.